Thank you for coming out for our Combat Robotics program. This is a part of our One Book New Canaan program to coincide with our two 2019 titles, Spare Parts and The Wild Robot. My name's Kayla Del Biondo. I'm the Digital Services Librarian here. I met Vladimir a few months ago at the Norwalk, the Fairfield County Makers Guild over in Norwalk, where I learned how to connect a temperature and humidity sensor to an Arduino microcontroller and configure it to send data to a crowdsourced logging dashboard. Say that 10 times fast. Vladimir is the founder of the Fairfield County Makers Guild, and he's the Makerspace supervisor over at Norwalk Community College. He helps creative minds utilize various technologies to complete all different types of projects. And he's here tonight to teach you about this robot that him and a few people over at the Guild use to compete in local duels. So those who are interested, we might have time at the end for some Q&A and for a few of the younger ones to try out the robot. So stick around for a few minutes at the end. We'll see how many we can accommodate. But without further ado, I'm introducing Vladimir.
All right, thanks, Kayla. Okay, so glad to be here. I'll start off with just talking a little bit about what I do, and then we'll jump right into combat robotics, and I'll talk about what that is. There's probably different levels of experience with that here. And then we'll go into the parts and how to actually make one, or basically the parts that come together in making combat robotic or combat robot. And then I'll leave some time in the end to take some questions. So, okay, so I'm Vladimir Mariano, and as Kayla mentioned, I run the Fairfield County Makers Guild. It's a makerspace in Norwalk, Connecticut. Well, of course, Norwalk. But we've been around since about 2014. It's a community makerspace, so basically, we've got 3D printers, we have a laser cutter, a small CNC machine, a little machine shop, a crafting, sewing area. We have a member right now putting together a jewelry bench. So we do a little bit of everything. And the way the space works is it's a membership-based space, so $50 a month you have access to the great creative community that we have, plus all the tools and equipment. You actually get 24-hour access to the space. And you're free to come and join. I always get questions about kids. You have to be 18 and older to join, but we do allow parents, if you have a kid who's interested in 3D printing or electronics, you're welcome to bring him or her along, but as long as you stay with them. Okay, so the other thing I do is I run the makerspace at the Norwalk Community College. Currently, the community college space is just for students and staff, but we are talking and seeing what can be done to open it to the broader community. I'm not sure why I threw this in here, but I think I just wanted to show you guys. This is just a project that we just did. Whoops. Okay. Doesn't really have anything to do with combat robotics, but I was just trying to show some of the stuff that happened at makerspaces. But the students realized that there was a problem with students leaving their book bags around, so they used the laser cutter to design this shelf to allow students to put their book bags in, and so they cut that up. I'm trying to navigate two screens now. I'm gonna have to figure it out here. No, not what I want to do. All right, give me a second. I'm gonna change this a bit. I'm gonna change this to make it a little bit easier on me. Just duplicate the. Okay. What's going on?
The tab at the top left, I think it opened your video anyway.
Did that? Is that what it did? Yeah. Oh, okay. There we go. That really threw me off. Sorry. Okay, so besides the maker spaces, I also run my own company called Desktop Mix, where I teach how to design specifically for 3D printing. So I create online tutorials and online courses teaching how to design. My website is desktopmix.com, and I also have a YouTube channel where I put weekly videos and tutorials, and Instagram page and a Facebook page. So if you want to follow my work, you can follow me there. All you have to do is just search for Desktop Makes. Okay, so let's talk about combat robotics here. I just want to let me make sure I'm on full screen here. Okay, so what exactly is combat robotics, and how, what, let's talk about what it is, because people have different ideas of what it is. I find like when I tell someone, sometimes they're thinking of like real like human robots fighting each other, and it really runs the gamut. Anyone here actually have experience with building a combat robot? All right, with school or school? Nice. Okay, so really? Okay, so we have a couple people here that are into it. So from what I understand, the way this got started, and this is from what I read, so I'm not sure how accurate, but it sounds very believable. Because I used to teach a regular robotics team, or I used to coach a robotics team. And actually, I've got one of my students here, my old robotics students, but I coached, and the format, this was FTC, First Tech Challenge, and the format is you'd have this autonomous period, and then you would have this part where you would pick up the remote controls and control the robots to finish a task. And they quickly found that the crowd got most excited when the robots would, sometimes accidentally, sometimes not so accidentally, bang into each other and kind of beat each other up. So then they said, well, why don't we just create an event where it's just that, where robots destroy each other? so that's what I hear from how that got started. So basically, what it is it's a robot competition where these robots are built with the purpose of destroying each other. So they get into an arena and they battle it out. If one robot is no longer moving and the other one can still move, then that robot wins. And if they're both moving, it's kind of like a boxing match. Then there's judges to decide, who was the better competitor. So, the term robot, though, honestly, most times these aren't robots. When I think of a robot, I usually think of something that is more like this, has sensors, is able to react to its environment, and is programmed to make decisions, right? So this is one of the Boston Dynamics robot, and that's a real true robot. No one is controlling a remote, controlling it to do something. And with combat robotics, you're really just talking about, you have a remote control. Although it's not out of the question, you can make them more robotic by, for example, you can give them sensors, and you could put the sensors on a robot and say, okay, and program it to say, whenever the opposing robot is within a certain distance, then automatically trigger the weapon and make sort of the weapon be autonomous. So, and there are people who do that. It's just most of the time it's not going to be really a robot. But like different combat sports out there, there's different weights. So you may see, for example, I don't know, anyone aware of the Discovery Channel BattleBots? Anyone watch that? All right, we got a couple people. All right, 3 people. So with the BattleBots Discovery Channel competition, you've got where the bottom of the list here, where you've got sort of the lightweight, middleweight, heavyweight. These are the 120-pound robots that fight each other. But then you have, on the top, you've got the beetle weight, which is a 3-pound ant weight, and the fairy weight. So the beetle weight is the competition that I'll talk about it in a minute, that we signed up for in Norwalk. But then you've got ant weight, that's 1 pound, and then fairy weight, 1/3 of a pound. And then as I was reading more and more, I found out, there's a flea weight, and then there's a nano weight as well. So they get really, really tiny. So you've got from 25 grams to 250 pounds robotic competitions that you can get into. So the big two places, the UK has sort of their own league and their own sort of organization, and then there's the North American League. They use the same classifications, but the weight classes might be a little bit different. So I'll, just so everyone kind of is on the same page here of what we're talking about, I'm going to play a few videos. I'm only going to play like a few seconds of each, or a minute or so, just to kind of show what the different robots and the different weight classes, what they look like when we talk about BattleBots. And this is the BattleBots show here. Let me, actually, we'll go ahead and play from the beginning. So I'm not going to have sound, but this is the Discovery Channel one, where it's basically, it's for TV, right? It's production, so there's basically no rules. Everything is allowed. There's flamethrowers, there's, you know, there's always something catching on fire. There's sparks flying everywhere. So all sorts of very high dramatic fights. So I'll do, here's another fight here.
Oh my God. Did some of them have gasoline in there or something? How did that fire?
Oh, they, as a flamethrower, probably did. Most of the times they're battery operated, although for this size, I'm not sure. They may have, no, I doubt it, because it's enclosed, and there won't be any exhaust, no way to hold exhaust, so, but yeah, for the flamethrowers, yeah, and they're shooting here as well, so, yeah, most competitions don't allow projectiles, so, or flamethrowers. Okay, so we'll, that's sort of the big competitions. And then here we're going, so that was the 120-pound battles. This is a 30-pound competition that they held in the UK here. It's too bad there's no sound, because that's like half of the fun here. This bar won't let me. Whoops, wrong button. Just trying to speed it up, but that little bar is in my way. Go away. What was that?
If you want to try it.
I think because it's, I would need to connect this.
Yeah, and you don't have some place in your laptop to do that?
Oh, okay.
It's like the headphone jack, I think.
Gotcha. That's what I was missing.
Try that.
No, is there a
Still
speaker
audio on?
connection here? Audio on? Oh, here we go. Hold on, sorry. Earbuds over here on here.
External speakers.
Yeah. Let's try that. Still nothing.
And that's definitely not muted, right? The YouTube one? Sorry about that. That's weird.
That's okay. Yeah. That's the only thing I need. Okay, so that was a little flipper robot there. And then let's go. So this is actually in Norwalk. This is a 3 pound. So we went from 120 pounds to 30 pounds, and now we're going to 3 pounds. And you've got a spinner robot there against what looks like a drum robot. And the guy who's actually controlling the spinner robot, the white one, he competed on the Discovery Channel BattleBots show. Yep. Yeah, you can see the live view there. Okay, I think that one's done. And then I'm going to show you the fairy weight. So this is 150 grams robotic fights. And you can see the orange one looks to be 3D printed. So These are little tiny, tiny robot fights. And these are the kinds you would probably find, if your school was going to host a robotic competition. It's probably going to be more along this size.
Videos you're showing, 'cause if you plug this in, it was actually the headphone option.
It is the headphone
Yeah.
option.
Yeah. I don't know if you want to try it or if you're wrapping the videos.
Try it one more time. That does not give me the option.
There we go. It's the headphone option.
Or let me try it over here. No. I think that's the kind of last one anyway. Okay, so as you see there, safety is definitely a concern when you're talking about battle bots, especially once you get to the bigger robots. But it doesn't even have to get that big, because even the smaller robots, with their spinning blades, things can fly pretty fast and get you in trouble. So at the Makers Guild, we actually made this enclosure there, and this is a little testing box for the robot. So the rule is, whenever you're spinning the weapon or you're trying out your robot, it has to be in this enclosed testing box. And also, when you go to these arenas, they're usually made of clear, shatterproof plexiglass, so that anything flying off, is not going to hurt anyone. And the robots will always be required to have some sort of safety switch on there, so that you don't plug your battery in and the weapon starts spinning and you can hurt yourself. So these are usually standard rules when you're competing, so you have to make sure that you follow these. Let's see, and this is our robot that we started with. You can see there, I'll show you the one actually we ended up building in a second. But one more thing I wanted to mention, these competitions, what they tend to look like when you go there, you'll see, basically you'll have your arena there, and then there'll be tables around, and people are quickly working and putting the robots together. They go and then they compete, and even if you win the competition, your robot is usually pretty messed up. So it's then going back to the pit crew, and they have all their tables with all their tools there and their spare parts. So you're usually having to replace a motor or go in and sometimes your tires get shredded from the other weapon, so you're replacing the tires. Switching your battery, and you have to be really prepared to really handle anything. Pretty much, you pretty much have to have a spare part of everything. And once you know your robot, you kind of know where the weak points are, so you know what parts are really going to need to be replaced. So it's actually a fascinating sight, just walking around and seeing people just repairing their robots right on the spot and going back in the ring. So we started with a robot kit here. So I haven't been doing this too long, but once we started, there was a group of us that really got excited about it. We said, oh yeah, let's build one, but we were thinking, okay, now how do we start? So the way we approached it is we just got a kit at first, and we said, this is going to be the best way to learn. And this is the way I would recommend if anyone's looking to get started with it, is buy a kit. Because when you get the kit, you get a box of parts, and then you'll put it together, and then you'll realize all the components and how everything goes together, and then you can always upgrade from there. So I've got, for example, I went from this here to this here, and you can see some changes. Now all the parts are the same, well, most of them, but I decided to actually 3D print a frame and then put a weapon on there. So here's the robot we have right now, and it's not completed yet. It still needs quite a bit of work, but so far this is what we have. And you can see here, I changed. So this is the weapon. I chose for the demo to replace it with a cardboard cutout of the blade here. Yeah, just in case if something goes wrong, I want everyone to go back with all the limbs you came with. But I'll demo this just to kind of show you how it works, and then I'll go over kind of the parts. I'll set up some props here. Just for some visual effect here. Okay, so whenever you have your robot and your remote control with a transmitter, you always want to turn on the transmitter first, because if you turn on the robot first, you have just a chance, it may receive some, stray signals and may actually turn on. So the way this one turns on, remember I was talking about sort of the safety switch, this little plug in the bottom, that's basically cuts off the battery circuit. So once I unplug that, it's gonna turn on. Then, so basically then we just control it. And you can see the fan there, it just spins. So then you would go into an attack. No cup, stand a chance. And it does really take some work practicing to get the steering right. To think, I've actually have this, so I have the cardboard cut out. And there's a way you can program the controller so it doesn't go past a certain speed. Because when I cranked this thing all the way up, I thought it was going to take off the ground. So I actually 3D printed a little like extra safety bracket here so that I won't go past the speed. But so this is a pretty tame robot compared to some of the ones that were at the competitions we went. But you start somewhere and you build up from there. But so that's what we have so far, and it works. So I'll then bring this up and I'll talk a little bit about all the parts that go into it, to building this. So when you turn it off, just you want to turn off the robot first. Okay, and this is actually, so I shot a video of laser cutting the part, so I can show you guys. Let me speed this up to 2 times. Whoops. PowerPoint is not liking me today. So this is a laser at the NCC Makerspace that I used.
What material is it kind of?
Cardboard.
Okay.
Yeah, it's this this blade right here.
Okay,
Yeah, and that's the thing. When you're prototyping, I find this is fastest. Cardboard and 3D printing really speed things along until you get a final product. You have a question?
how long did it take for that to cut?
To laser cut, that was probably less than 30 seconds to cut. Yeah. Yes. Yeah, when you do the competition, most of the robots are metal. There are some people who experiment with 3D printing, but mostly they're not using PLA. I don't know how many of you are familiar with the 3D printing material, but they're usually with using PETG, or I saw some nylon robots, some carbon fiber, actually 3D printed carbon fiber robots. One team was actually sponsored by, I forget the name, but it was one of the carbon fiber 3D printers. So yeah, usually you're seeing those types of materials. I'm planning to start a similar competition at the college, and what I think I'm going to do though is limit it to just plastic, limit it to parts that you can 3D print or laser cut, to be able to encourage people to really learn the design software, design program, and learn how to operate the machines. Because otherwise, when you go to these competitions, they just kind of, surround the robot with stainless steel, and then you see these matches. Some of them are fun, but a lot of them is just like 2 stainless steel robots. There's just sparks flying everywhere. Yeah. So. Okay, so let's talk a little bit about the parts that go into making the robot and putting it together. So, okay, you'll have to bear with my own little drawings. I got an iPad with a pen, and I find an excuse to use it. So I decided to make my own parts, my own little drawings here. But I'll show you some real pictures of what these parts look like if you're interested in making your own. Okay, so first we're starting with the transmitter or the remote. Same thing, that's this here. So what we want to do is get to a point where, right, if I move these joysticks here, it's gonna control a motor, okay? So there's a few steps that we have to take in between. So with the transmitter, it comes with a receiver. And the receiver will have different channels on there. So the idea is when you control one of these joysticks, it's going to move one of the motors that's attached to one of those channels. So, but before you can actually get to the motor again, you know, if any of you have ever just connected a motor to a battery, you'll notice that it'll just spin constantly depending on the voltage of the battery. If you want to be able to regulate the speed, you actually have to attach what's called a speed controller to it. So you'll see these and they'll be labeled as ESCs, or electronic speed controls. And so you need one of those in between. They look like this. You know, it's just, they're usually around this size, sometimes bigger, but they'll have these wires coming out of them. And from the speed controller, now you can go to the motor. And then in the motor, you'll want to attach it to your wheel. My robot right there is direct drive, just meaning the motor is connected straight to the wheel. Some robots can you know, be connected to like a pulley, then that's, or maybe some belts, that's then turning a motor. And then of course you need a battery to power everything. So this is what sort of one side of the steering would look like. You've got the transmitter sending that radio signal to the receiver, and then it's going from the receiver to a speed controller and then to the motor. And then for the other wheel, you just have the same thing. You would then use another speed controller and another motor. And then for the weapon, again, it's the same thing. You would use a different channel. You would use a speed controller and the motor weapon. So that's basically the parts in a nutshell. I mean, those are, no matter if you're, you know, making a small little nanobot or, you know, a huge robot, it's just going to be the difference in the size, you know, basically size of motor, the size of the battery, how much voltage and amps the speed controller is going to be able to take. And so what we did with our kit, we used this website called FingerTech Robotics, if anyone's looking for resources. It's a website that this is what they specialize in, is combat robotics. So here you can go and you can find all sorts of kits and parts if you want individual parts or you want to start with the kit. And so I'll show you guys some, these are all parts we got from there. And the thing is, you're going to end up paying more if you go with this because everything is kind of together. But once you know what you're doing, then you can go, you know, then you can go into eBay and then shop around for exactly what you need. And then you can save a lot of money. But I would definitely recommend, because there's enough frustration when you're trying to build and you don't know exactly what you need. I mean, even with this, we realized we got one of the electronic speed controllers didn't work with the battery we had because it required more voltage. So we had to then get a separate battery. And once I got the battery, I found out, oh, it has a different type of connector than what I need. So, you know, so there's so many ways to go wrong that is just, in the beginning, just, you know, learn how things actually go together by getting a kit and then buy your parts separate once you know what you're doing. So here's the transmitter. Again, it's the same thing as I showed you. This is what the receiver looks like. So you'll see it'll have different pins on the side, and here it's labeled from channel 1 through channel 6. So 6 different channels. You have 6 different slots where you can plug in motors to be able to control them. This is the electronic speed controller. So the one in here, the black wire there, or the black plug would go into the receiver, and then it's got 4 wires, 2 going to the battery and 2 others going to the motor. The battery we're using on that robot, it's a small battery. It's most competitors are using LiPo batteries. This is a 7.4. I usually see the 7.4 or 11.1 volts when people are using batteries. Depending, sometimes with the 3-pound robot, you know, or the 1-pound robot, you have to take the weight of the battery into consideration. So you don't want to use a battery that's too big if you don't need it, because it may put you over the weight limit to actually compete. And then here's the motor. Now the motor, you're going to want a geared motor. So, and they're gonna be, they'll have a gear ratio to them. The one I'm using, they're pretty small motors. Here's the actual size of these little ones here. So they're 33.3 to 1 gear ratio. So you wouldn't be able to use just a regular like toy DC motor because if it doesn't have any gears in it, it's just going to spin way too fast. So the whole bottom part there, that's just a motor, and then the top part of that, that's actually the gear train in there that allows it to slow down the motor and give you more torque. So that you can actually be able to control the robot, and you have that additional torque that you can actually push, another robot out of the way. Okay, so I'll talk a little bit about the different types of motors. Right now I just mentioned the gear motor, and usually for driving the robot, you're looking at geared motors. For weapons, a lot of people are using brushless motors, and these are the same types of motors that you would use, for example, like a quadcopter. They spin really, really, really fast, and so people would usually you can either attach a weapon directly to that or have some type of pulley system going to the weapon. And then the other type of motor are servo motors that are popular with these, and the servo motor would be used mainly if you have like a lifter robot, like the one in the video where it would it would launch another robot out of the ring or try to flip them upside down. You would use this. And these would mainly be used for like the smaller robots. The bigger robots, they're using pneumatic devices. Okay, so now I'll talk a little bit about different types of, or the styles of combat robots. This one is just a wedge robot, and the idea is it's meant to try to just get under the opposing robot and to try to flip them. A lot of robotic competitions, though, don't just allow wedge robots. You actually have to have an active weapon. So the wedge style of robot, the wedge is usually, it's combined with something else. So you'll have a wedge plus either a hammer or some type of spinning weapon on there. This was at the last competition I went to. This is a flipper robot. So this would use a servo motor to actually lift that fork up to try to either flip a robot upside down, or if there's a way to get them out of the ring, you can do that. Some competitions, after a few minutes, they'll have like these trap doors that open, and you can shove robots into them. This is actually printed it's 3D printed, and it was made out of a TPU. Some of you may know it as Ninja Flex, but it's the rubbery 3D printing material, and I was impressed how well it held up. Here are spinners, so 2 spinners going at it, and spinners, their strengths are that, their weapon is also their defense, because you're not going to attack them by their spinning robot or by their spinning part. But they can be a little tough to control, and the problem with these is usually they end up taking as much hurt as they sustain, because when they hit another robot, they tend to do a lot of flipping too, because it throws the robot also, especially with the smaller weight classes where you can't have much mass to hold it down. But they're pretty effective. This is a drum robot where it uses a drum in the front, and usually I've seen these with they'll have like bolts in the front, and these are really effective for just really they can throw robots really far. Like they'll go up against another robot and just kind of launch it up into the air. But then the problem with these is that the massive drum in the front, usually you want a lot of mass in there, which can make the robot hard to control. So that's that presentation. And I want to show you guys sort of a neat feature of the website here. So as I mentioned, I designed the frames here for my robot, and I wanted to right off the bat start designing my own frames, because I mean the thing that I actually enjoy about this type of competition is, it's not so much the destruction, but it's kind of being able to design, giving you an excuse to go in and use all these tools and learn how to use a 3D printer, get better in your design, use a laser cutter. And once you start designing and you have the flexibility to make your own designs, you know, then you can start improving on that. So this is, you know, so I've got a couple, you see a couple designs here where I made, for example, we have this little caster wheel in the front. All that is a marble that's pushed in there so the robot could have a wheel in the front. But there, when I was making the body, there was some problems with the placements and things not working out. So you're constantly iterating and coming up with better ways to design it. And once it actually competes, we'll be able to see, okay, so this part isn't working, let's fix this part. And the neat thing with the website here is if you go under, they have these tabs, and they actually give you the drawings. So you can get the PDFs of all the different components here. And then they have a version called IGS, which is the 3D model. So I'm going to bring up the design software that I use, Fusion 360. So basically, I was able to go on that website and say, okay, this is the part we're going to get. And so I can go ahead and download it. And when I bring it into the design, I could then use that design to modify it and start thinking about how I'm going to 3D print it. You have a question?
Would this kind of thing work in like Autodesk or something?
Yeah, so IGS, it's one of the sort of common formats that you can pretty much take it in and import it into, you know, any of the popular CAD softwares would be able to take it. So I brought that in, and then you can see all these are different components. So I can actually come in and remove that top and that front here, and then I can actually take a look inside. And you see it's not just a shell. I actually have the receiver here. I've got the speed controllers. I've got the motors here, you know, the wheels. And if I want to see, if I want to design my own hubs for the wheel, I can find where, you know, kind of remove that and take a look in there and start experimenting with my own designs. So that's it's a great learning tool to be able to come in and just, you know, go off of their design and start making your own. In fact, so for the weapon here, I used their weapon, and when I laser cut it, I just exported this into a file format that I could laser cut, and then so that's how I was able to get it to the laser and cut it out of cardboard, because then that allows me to see, you know, how this is going to work. Because when I first made this, I had a problem where it was actually it was hitting, you know, the wires over here, and so I had to realize, oh wait, this is not going to work. So then I pushed it back, and I realized, oh, now it's hitting my tires, so that's not going to work. You know, so you know, you can do that within the design, or you can take it part by part and just kind of, you know, assemble it out of cardboard, and you can, you know, it's better to find out this is hitting my tires with cardboard than it is with actual, you know, steel or aluminum. So. And then, so what I did was I actually, so this, even something simple as this, like this motor mount, I mean, I can buy this for how much they're selling it, $5, but sometimes I don't really need the part in aluminum, so I can save my money and just 3D print it, actually. And I also have the exact dimensions instead of trying to go and trying to measure and being a little bit off when I 3D print this. I can just take their files and 3D print them, and I can save a lot of time. So here's the one I made. Let me bring this up here. So this is the body. Actually, this is the body here. Let me get rid of this for a minute. So this is the one that I made, and you can see I have my mounts there for, this is where my weapon motor, and then the caster wheel there, and then the actual drive motors in the back there. And that's how I was able to make it. So this, I didn't bring in the 3D model. I actually brought in the PDF file. And what I did was, if I, see, I'll erase the body and I'll show you. I was able to just bring in the dimensions there and then use that to just make my part, dimension it, and then create my body here. So this is a pretty simple design, but you know, for the first sort of iteration, I've chose to keep it sort of simple. You can get really creative with this. I'd love to kind of just actually have an idea to go and make like a, you know, like a Mario Kart turtle shell, you know, type of body for it. Something that looks very innocent, but then, you know, is a destructive machine. Yeah. So, but it doesn't really matter the shape, because once you have the exact dimensions of where the holes and the motor mounts are going to go, you can pretty much, you can get as creative as you want with this. So the nice thing with Fusion 360 is I can play the timeline and you can see sort of the approach. So I'm just going to hit play there and you can see how I took the sketch. And just kind of added each part as I built the model. Let me see. I can go into. I want to. I'll take like 2 minutes here just to show you how that works. I'm gonna bring in that that PDF. So right now I have that here, and I want to just show you guys how simple this is, because it'll show you really that anyone can really do this. Now, this is not going to be like a step-by-step tutorial. I'm going to go pretty quick, but I just want to show you how you can actually, start doing stuff like this. So I'm going to take this drawing right now, and it's just a canvas. It doesn't come in with any dimensions, so the dimensions on it don't really mean anything. But I'm just going to line it up here, and then I'm going to create a sketch. And this is a pretty simple design. All it is kind of 2 rectangles. So I'll basically just create one rectangle here and then another rectangle on top. And then I can come in and, actually before I do that I skipped a step. You actually have to calibrate this because it doesn't come in calibrated. So I'm gonna take this image here and all I have to do is find a dimension. I'm gonna use this 166.24 and type that in, and that'll automatically calibrate the sketch for me. So now I'm just going to move that into place so it's sort of lined up with the origin here. Okay, now I can begin sketching, where I'm just going to go ahead and draw my rectangles, and you can see the dimensions are pretty close here, but I can go in and give them exact dimensions and just reference what I'm seeing here. So this side I can see is 48.33. So I'm going to put that in. So you can see how quickly you can get something like this build. This is 55.86. That's 36. And so you can just go ahead and trace these. Okay, and then once you do that, basically all I'm going to do, just to kind of delete this line, I'm going to take that sketch and just extrude it out. I'm going to go 30 millimeters, and then I'm going to apply what's called a shell, and then just shell this 10 millimeters. And then I can do stuff like, okay, I want this to be a little bit longer, so I'll bring it out. Maybe I want this to be like a wedge shape, so I'll take this and kind of move this out, maybe 45 degrees, and then if I want my motors to be mounted on the side here, I can create a sketch here, throw a circle on there, and then maybe just extrude that. I mean, I would dimension it, but I just kind of want to show you quickly, and you can start quickly making your design. Anyone here work with a CAD software, or specifically Fusion 360 or anything? Which one? Autodesk and Tinkercad. Okay, great. So and you can do this with any one of those, but just to show you how you can quickly begin designing. I think that's pretty much all I had for a presentation. Anyone have any questions? Yes.
Do you have any specific kits that you recommend on the website?
So yeah, we started with this. Just a regular, it's the Viper, and it's just a wedge. It doesn't come with a weapon or anything, but you get all your parts. You get the 2 motors, you get your electronic speed controllers, you get your wheels, your hubs to connect your wheels. So yeah, once you start with that, then you can expand to the.
So it comes with all the basic pieces that you would need to start building?
Yeah.
What does it cost?
This is $150 for the kit. And so that doesn't include the radio. If you want the radio, it's another 64 Canadian. So this company's in Canada, whatever that is. Yes, up front. The design part, the design software. It depends. With Fusion 360, it's not so bad. You don't need like a very powerful computer. But if you're using like Tinkercad, for example, that's just you're going to a website and designing. You can do that with any computer. Yeah. So the answer is mostly yeah. Most computers can get away with at least this software that I'm using. Yeah. Yes.
Can you see any flying robots in the competition, like robots?
Not from the one I went to, but I think on one that they did on the Discovery Channel, I actually had one that was flying. There, did you see it? Did anyone see that? You did? Yeah, cool.
Are there rules on what you can do and what you can't do?
Yeah, so there are some places will have their own rules, other places will follow they'll list like whatever the organization is that they're following. There's like regional rules for certain combats, but yeah, generally, there's no liquids, so you can't just spray a liquid in your opponent. You can't throw a net. There was, when they allow projectiles, this competition that I went to it actually had a speed. Like you're allowed projectiles, but it can't go faster than this. And I don't know who's measuring, but but they did have that. There's sometimes rules for spinners, for if your weapon is spinning, of how fast it's allowed to rotate. Usually no flamethrowers, but depending on the class you're in too, it'll be required, like whatever the weight class is, you cannot be over that weight, and there's usually a size constraint as well that you'll have to be in. Yep.
What is the file format for laser cutting?
For laser cutting, the popular ones are DXF and SVG. Yeah. Yes?
Can you show us how this robot works?
Yeah, I did. I can show it again. So the one here, so basically you turn on the transmitter first, then you pull out the safety plug here. And actually, let me see if it'll, yeah, sometimes you always want to make sure that whatever, I'm using this button here for the weapon. If it's up, usually the robot won't start. It has to start in a down position, which is a nice safety feature. So this channel here is controlling the left and the right motor. So I'm only controlling it with my right hand. So I'm going up and both motors are turning on. Going backwards, both motors are going backwards. When I go left, it's going to spin the left motor back and the right motor front. So that makes the left turn and then the left turn. So it's basically, it allows it to like just kind of spin in place. And then the weapon. I can tell you, like, I'm a pretty bad driver. This is if I can get that cup out of the ring. There. No cup stands a chance. So that's, and I can tell you, if you're trying to get into combat robotics, I think what happens are most teams, they spend like the whole time building the robot. It seems like no one practices driving because everyone seems to be really crappy drivers. They have these amazing machines, but they can't hit their target. So you'd probably be at a big advantage if you just build something and take a lot of time to practice controlling it. Yes.
How do you get the weapon to spin?
So there's a motor connected to the weapon, and then I use this joystick right here that controls the throttle. So if I bring that up, the weapon spins.